Good evening, sir. Myself, M. Balasubramaniam. So, my supervisor is RS from Weltech University Chennai. So, my paper title is A Comprehensive Review of Conventional to Modern Algorithms of Speech Enhancement. So, my abstract is speech enhancement is nowadays almost all of the modern communication systems are used. So noise is the major problem in all the aspects. So speech enhancement is an area of digital speech signal processing that aims to recover the clean speech from the trained signal. So in all the aspect means clouding areas, cinema theaters, railway stations, bus stands, whatever it is, the clouding areas that all are the noises are present. In this one, original speech degraded by the this noise signal. So our aim is to remove the noise from the original speech signal. In this regard, we have so many conventional techniques are there. So in this regarding single channel speech enhancement methods and multi-channel speech enhancement methods are there in the previous conventional methods, and also machine learning methods like neural networks, deep neural networks, convolutional neural networks, residual convolutional networks are under the machine learning techniques. So machine learning techniques are much more better than the previous conventional methods to reduce the noise and give the more efficiency. So in order to increase speech quality of the signal by using the machine learning algorithms, so almost improvement is done at the percentage level of 98 percentage. So in this regard, my future point is to improve the efficiency above the 98%. So the next slide is introduction. The speech enhancement is one of the most important technique to de-enhance a nice speech, and it improves the quality of the speech signal. Speech enhance has been long used as a processing step in various speech related applications. The applications are so many things: mobile phones, speech recognition, hearing aids, and all extra communications, and so many communications also. So these are the basic conventional methods of the speech enhancement. So it can be divided into different categories. Time domain approaches. The time domain approaches under the Kalman filter, adaptive filter, home filter, linear predictive coding based filtering, and neural network. These are the time domain approaches of the conventional neural networks. Next, coming to the transform domain: spectral subtraction, wavelet transform, stochastic estimation, Wiener filter, and minimum mean square, DFT, perceptually motivated Bayes estimation, etc. etc. And also supervised learnings are decomposition based supervised techniques, and the modeling of the speech bias is supervised techniques. So these are the main conventional methods of the speech enhancement. So in this one, single channel speech enhancement methods, especially in the time domain, Kalman filter. It is one of the best filter in the previous days, and the adaptive Kalman filter nowadays also very good, but it is some of the drawbacks are there comparing to the machine learning techniques. So it is the quicker convergence time, which leads to a shorter time until a valid state is observed. So the drawback is large computational complexity to get the better results. So next in the time domain approaches adaptive filter. An adaptive filter is a device. It is used for computational purpose mainly, and endeavors to create a established association between two signals in real time in an iterative style. This is about the adaptive filter. So and next, transform domain approaches spectral subtraction. So it is one of the best method in the transform domain approaches. The spectral subtraction is efficient in computational, and it has most was. The drawback is introduce the musical noise in the spectral subtraction method. And next, Wiener filter. Wiener filter is less complex in terms of computing the calculations. It is the best method. There is a wide room for improvement in the performance in rooms with moderate preparation. So minimum mean square error estimation. It has less computational assets and resources. There is the absence of the mechanism in order to control trade-off between speech distortion and remaining noise. So it is the drawback, but it is computational assets and resources are very less. Uh, least square. So in this method, it is the quicker convergence rate as compared to the previous LSM. So it's like so next it is affects the most restrict to the periodic noise, the low frequency noise signal subspace. It is one of the method in the transform domain approaches. It delivers a mechanism to control trade-off between speech distortion and remaining noise. The results in the heavy computational loads. Multi-channel speech enhancement is the next one. In this one, adaptive noise cancellation having the LSM and RS. So in this regarding, so adaptive noise cancellation system assumes the use of two microphones. The provides user to more personalized noise cancellation and improves the sound quality, larger, better life. So LSM algorithm very simple and easy to use, and the gradient noise amplification is somewhat complex. So has quicker rate convergence and compared to LSM. So it affects most restricted to the periodic noise, the low frequency noise signal. So next one, multi-sensor beamforming in the multi-channel speech enhancement. It is a specific type of multi-sensor signal and it improves the signal to noise ratio. So it is providing the better results and also controls the direction of the uh, antenna signal. So it works by the combining the information from several distributed sensors and directions of directionally filter information. So these are the machine learning technique. Nowadays, so many sources we are using the machine learning approaches. So first one is a neural network for speech enhancement. So in this one, it is very simple computational architecture, and reduce the processing time. Very important this point. Accuracy may be better. The generalization performance under uncertain settings is particularly strong. Deep learning neural networks better performance compared to the previous things that the methods least minimum mean square error and signal to noise ratio based on algorithms. So really good at managing disturbed loud voice recorded under the various conditions. So need it has the drawback is need more training and convolutional neural networks. It is also the better performance compared to the previous results and improved noise reduction with unknown signal to noise ratio levels. But to train efficiently needs a lot of label data. It is the drawback in the convolutional neural networks. And then go to the residual convolutional neural networks. So properties assist in the reduction of the noise even low SNR conditions also. The majority of the other speech models are fails. So it is provides a better results even though low SNR conditions. So next optimization techniques for the speech enhancement, BAT algorithm and modified BAT algorithm. So it solves a wide range of problems and highly non-linear problems. It gives the promising optimal solution. This is the better thing in the BAT algorithm. Modified is the so advanced one of the BAT algorithm. It implement certain say adapting fuzzy system to dynamically adapt the parameters such as wavelength, loudness, and low frequency. So these are the some of the references I referred. So in this first paper, 2022 paper, the title is Deep Noise Suppression, Maximizing Non-Differentiable PSQ Mediated Buoyant 9 Noise Sensitive PSQ net. In this one, so our techniques used non-inductive PSQ net and fully convolutional neural networks. In this paper, got the some of the points and some of the advantages and disadvantages. So this method, see, RRN model is a model to remind each information throughout the time, so it can process inputs of any length. Drawback is one thing, due to its recurrent nature, the computation is slow. And next one, a deep learning approaches for noise removal and enhancement of a real-time audio signal. So in this one, LSTM method is used to noise reduction is better, enhancing the voice signal, and noise reduction is moderately high, but not reduced properly, but somewhat better. So next one, a convolutional network with multi-scale and attention mechanism for end-to-end single-channel speech enhancement. So in this one, using the technique is end-to and single-channel speech enhancement, and the pros of this technique is improves the learning ability, and training of this model can be difficult. So next is technique is speech enhancement is phase sensitive mask estimation using a novel hybrid neural network. So in this one, using the hybrid neural network technique we are using, and prompts are recognized phase sensitive mask also to make the complexity low, and is very low complex, and the speech distortion moderately high. So next thing, hybrid deep learning approaches for single channel HFSSP speech enhancement. So in this one, single channel SSP techniques used. So effect of eliminating the channel fading, noise suppression is very good, and needs more training in this one. And dense CNN with self-attenuation for the time domain speech enhancement. In this technique, you are using the dense convolutional neural network. So its spectral magnitude loss is very low, and is improvement in the speech signal to noise ratio. So drawbacks is the complexity. So from the literature review, I got the some of the objectives. So to reduce the maximum of the background noise, the means improves the quality of the speech signal, and improves the intelligibility of overall perceptual quality of the decreated speech signal using the audio signal processing, to understanding and comprehending what was spoken using the speech recognition techniques. So next to my project, PhD work, doing these three objectives mainly, as reduce the noise. Next thing is the speech enhancement, and speech recognition is the third objective. So some of the previous registered results are comparison PSQ along with the segmented signal to noise ratio, perceptual evaluation of speech quality with the some of the machine learning techniques, neural networks, DNN, CNN, at the different noise. We are taking the four noise cases: table, factory, street, and rest are places. We have got the noises. So how to reduce and how to enhance, how to recognize this based on the some of the parameters. That is the two parameters here, PSQ and the segmented SNR. So at the 0 dB level, we got the sum of the points, and various methods of performance of 6 dB SNR levels. So in this one also, at the Babel factory street restaurant, what is the PSQ and what is the segmented SNR listed in this table. So in future, my paper compared to previous results, our expected results is very efficient compared to the previous existed methods. So these are the references I referred. Thank you very much for giving this presentation. Thank you very much.